Today, on how it's made. Amphibious vehicles. And you thought wet and dry hand vacs were cool. Putters. Put on your golfing shoes. We're taking you clubbing. Model ships. We'll piece together the story of how they make them. And drumheads. We'll visit a factory that moves to the beat of a different drummer. A vehicle is amphibious when it travels on land and water. This one's used mainly by hunters and fishermen, but also by utility companies and the military. Wide, rugged tires easily trek through mud, snow, and bushes. When the vehicle's in the water, the tire's deep treads also function as paddles. This 8-wheel model can carry 6 people on land and 4 in the water. Buoyancy requires a lighter load. They begin production by welding 8 steel sections together to make the driver's seat. Then, 12 other parts for the vehicle's main frame. This frame will later house the seat, a gas tank, the battery, and a storage box. A worker assembles what's called the axle hub. A robotic press punches 5 bolts through the components to fuse them. This design keeps the hub lightweight and strengthens the axle for driving on rough terrain. Next, a worker inserts what's called the axle shaft through the hub. A robotic welding machine then fuses the shaft to one side of the hub. After he flips it, the machine welds the shaft to the hub's other side. This company uses a robot for this important step because it's faster and more precise. Here, a worker reveals some of the vehicle's secrets to functioning in water. Each axle's bearing has rubber and steel collars called flanges. They form a waterproof seal over the axle. The worker greases these flanges to lubricate them and to keep dust and water from infiltrating. He inserts one of 16 gaskets between the flanges. They're made of cork to keep moisture out and grease from escaping. After adding another flange and a gasket, he applies a liquid compound to rust-proof the steel shaft. Here, a computer-guided cutting tool carves teeth on a steel ring to create one of the vehicle's 17 gears. Lubricant cools the heat this generates so that the machine doesn't overheat and break down. When the cutting's complete, robotic arms remove the gear and replace it with a new unshaped ring. The gears range from about the size of a coin to the size of a dinner plate. Here's how the shift lever changes the gears from neutral to low to high and into reverse. And here's how the clutch will transfer power via a component called the input shaft into the transmission. A worker hooks up the transmission to the engine. Then he slides 2 clutches onto the input shaft. He attaches each one with a bolt and 2 washers, then connects the engine to the transmission with a rubber drive belt encircling the clutches. 2 brake calipers connect the brake system to the transmission. Now he tests the drive belt, clutch system, engine rotations, brakes, and steering. The wheels don't turn. The driver steers the vehicle by slowing or braking either set of wheels and skidding to one side. To make the vehicle's lower body, they take a sheet of polyethylene, a heavy-duty plastic, and heat it in an oven. After 4.5 minutes at 232 degrees Celsius, the sheet emerges softened by the heat. An aluminum mold drops down, and a vacuum-forming machine stretches the plastic around it, sucking out the air from between the two. After the plastic cools for 4.5 minutes, the machine lifts the mold, leaving a cavity about the size of a large bathtub. Two workers then move the lower body to an assembly line. They insert the vehicle's main frame, now painted black. Then, on the outside, they mount 4 extensions that'll carry the vehicle's 2 front and 2 rear axles. These will enable the axles to withstand greater punishment. They install 8 drive chains onto sprockets on the axle shafts. Then, 2 more linking the transmission to the components that propel the vehicle, what's called the drive system. A worker then attaches an end plate to complete the link. Workers lower the 26 horsepower engine into the carriage and attach it with 3 bolts. Next, the polyethylene upper body and then the wheels. They test the drive chains for tension and sprockets for vibrations. The wheels are twice as wide as most car wheels, but 10 times softer to cushion the ride. On land, this $16,000 vehicle travels up to 35 kilometers an hour. Top speed in the water is only 5 kilometers an hour, but hey, you'll make quite a splash. Golf players in 17th century Scotland were the first to hone their game by using differently shaped clubs for specific tasks. Today, you use what's called a putter to gently roll the ball into the hole using the fewest number of strokes. The club's high-tech, streamlined design is crucial to any golfer's putting strategy. This company uses a robotic tester to spot-check its putters for quality. The club passes if the balls roll along a straight line into the hole. That means the putter's striking with just the right impact. Production begins with bars of aluminum, a metal that's lightweight and easy to sculpt. A bandsaw slices them into 11-centimeter long pieces. Each piece will become a putter head, the part of the club that hits the ball. A computer-guided cutting tool sculpts the heads by shaving away up to 1/3 of the aluminum. The machine first mills one side of the head into tiny steps. Another cutting tool then shapes this area into a smooth curve. The process takes 10 minutes. Then the 4-sided platform revolves, and the cutter begins working on the next putter head. Another milling machine carves blocks of copper-nickel alloy into what's called the insert. This part will fit into a cavity in the putter head, making the area that strikes the ball firm yet resonant. It's why the golfer feels the impact reverberate through the putter, what's known as feedback. This device performs random quality checks of the insert cavities in the putter heads. A vise holds the head as the probe gauges the cavity's width and depth. Next, these chunks of copper go into a chemical bath with putter head models made of different metals. The material from which a putter head's made determines the weight and feel of the club. This 10-minute bath removes any contaminants from the surface of the metals and coats the heads in copper. This ensures that the plating they're going to get will stick. After that, the heads are plated in a different metal. This determines how the club looks. For this, chunks of matte-finished nickel go into a second chemical bath. They'll provide one of this company's 4 finishes, ranging from matte to shiny. During this 15-minute step, a mechanical arm occasionally shifts the rack to disperse the chemicals and thoroughly plate the heads. To fit the insert, a worker first positions the head in a vise. He applies 4 drops of epoxy glue inside the rim of the insert cavity. This provides additional bonding once they force the insert all the way in. After placing the insert in the cavity by hand, a worker uses a press to force it inside. They cover the press with paper so it won't scratch the insert, which must be flush with the surface of the head. Any air under the insert escapes through a hole underneath, where they'll insert the club shaft. A worker first applies glue inside the hole. Then he inserts the shaft and secures it to a template with rubber bands. The shaft is made of stainless steel. They usually come in standard lengths of 84, 86, or 88 centimeters. They're set at the angle most players prefer. The next step is to mount a hand grip at the top of the shaft. First, a worker wraps the top in double-sided tape. Then he pours water over the tape to dilute the glue on its surface. This will enable the grip to slide on more easily. He pours water inside the grip as well. The grip is a rubber sleeve that's 25 centimeters long. Once lubricated, it shimmies over the shaft for a snug fit that lasts up to 3 years. He lines up the flat part of the grip at a 90-degree angle with the flat part of the putter head. This helps the player strike the ball properly. Next, a worker colors the club's engraved logo. Using a tiny nozzle, she applies minute amounts of epoxy paint inside the grooves of the design. She controls the amount of paint with a foot pedal that releases pressurized air into the nozzle. This company makes putter heads in some fairly luxurious materials, including beryllium copper. That one's for players wanting a club with a softer feel and who don't mind paying up to $500 to get it. Model ships are made for navel gazing. They're representations of real ships. Some are built meticulously to scale with extreme attention to detail and are truly museum pieces. You can buy model ships pre-assembled or in kits, but don't rock the boat. They're made for you to admire, not play around with. The Portland steamer sank in the Atlantic in 1898, all lives lost. But its image survives in models. To make a model like the Portland, a worker selects some wooden pieces from a stockroom. Model ships are actually made of thousands of parts, big and small. These are just a few, and some are to be cut down. A computer guides a laser beam as it carves the larger, flat pieces of wood into many parts. They'll be components for the ship's deckhouse. Next, a worker shapes a hull or main body using a machine called a duplicating carver. Holding the machine's stylus on the left, he traces around a master shape. This motion guides two routers on the right as they chisel into basswood, making exact copies of the master hull. To make resin parts, they mix polyurethane with some plasticizer and pour it into a mold. A chemical reaction causes it to harden. This takes up to half an hour. And then they pull a newly shaped lifeboat out of the mold. Next, a worker cleans up another mold to make it ship-shape. It's to be used to shape cast metal anchors. He places the mold in a centrifuge and pours a melted mix of tin, antimony, and copper into it. The centrifuge spins, and this causes the metal to fill the cavities in the mold and solidify. He opens the mold and finds the anchors formed like spokes around a hub. It's anchors away as he snips them free. Next, a worker sands smooth the bottom of the hull. Then he positions the first of the ship's 5 decks. He glues wooden spacers between the decks. A special glue that dries in about 10 seconds allows him to work quickly as he builds the tiers. Next, he submerges a deckhouse side piece in water to soften the wood. He cuts the little tabs to free other deckhouse parts from a matrix. After that, he carves out the center of 2 of the pieces. Then he glues a block between them and applies more glue to the edges. He bends the deckhouse side, which is now wet and supple, around the structure. The moisture causes a chemical reaction in the glue, which strengthens it. After he positions the deckhouse starboard side, he sticks a strip of clear acetate to the back of a band of windows. The acetate simulates glass. He paints the front of the windowed wall white and then turns it around to paint red curtains on the acetate. Other detailing has been laser etched into the wood. He glues the wall of windows between deck tiers, and the look is authentic. He positions paddle wheels on each side. These have 57 wood paddles held in place by brass radials. Remember the anchors cast in the centrifuge mold earlier? He now positions some on the ship deck. Then he prepares the lifeboats. The larger plastic one goes on the upper deck. This golden eagle is the finishing touch. Here, another worker rigs up a four-masted schooner. Using surgical clamps, he pins the ropes down so they don't get in the way. Then he measures a piece of decking to make the top of the deck house. He glues it to a base and then positions it on the ship. Next, a jeweler's lathe spins a piece of brass as a worker manipulates a cutter, milling parts for the ship's bell. Once it's mounted, this ship model is ready for a sea of admirers. A drum's playing surface is called the drumhead. It's the part of the instrument that vibrates, creating sound. Some drumheads are still made the traditional way, from animal skin. But a natural skin is very susceptible to temperature and humidity changes. So most drummers today prefer heads made of modern synthetic materials. The drumhead surface is often called the skin because traditionally it was made of calf skin. This synthetic skin is a flexible plastic film called polyethylene terephthalate, the same polyester-based plastic they use to make soft drink bottles. Workers load several sheets of it into a press that applies 75 tons of force onto sharp, circle-shaped dies, pushing them upward through the film sheets. The die-cut film circles become the skins. A skin can be made up of just one film circle or several taped together. Workers assemble the layers using a vacuum turntable. The suction keeps the bottom film steady while they apply tape to its outside edge and then adhere another film on top. Each layer is called a ply. The more plies a skin has, the more bass frequencies it'll produce. Now the skins go onto a computer-guided drill press. The machine drills tiny holes all along their perimeter, about 3 millimeters in. The holes are roughly the size of a nail head. They're spaced about 6 millimeters apart. The next machine heats the edge of each film to soften it, then applies pressure to mold it to shape. The skin comes out with a fluted edge, like what you see on a paper muffin cup. This shape keeps the tension even when the musician tightens the skin to tune the drum. Meanwhile, this roll-forming machine uses a series of pressure rollers to gradually shape an aluminum strip into a hoop. The hoop will hold the skin tightly over the drum's body, called the drum shell, creating the tension you need to produce sound. This machine also imprints tiny dimples onto one side of the strip. When the factory later glues together the skin and hoop, this rough texture will improve the bond. Now the machine folds the edges of the strip inward to create a channel on the inside of the hoop. That's where the glue will go. Once the machine finishes forming the hoop, a small built-in circular saw cuts the end. A worker then loads each hoop onto a rotating soldering jig, positioning the ends together. The rest is all automated. A glob of silver solder on the joint, then natural gas torches fuse the hoop closed. After water cools off the hot metal, the jig ejects the finished hoop. Drumhead hoops can be as small as 15 centimeters or as large as a meter in diameter. Finally, it's time to fit the skin into the hoop. This is the tricky part because the film must be perfectly level and centered. Otherwise, when you tighten the skin to tune the drum, the short side would tighten before the rest, and that uneven tension would throw the tuning off. So they do this critical assembly step on a specially designed table, placing the skins on circular vacuum fixtures that are perfectly level. As suction holds each one steady, A robotic arm runs glue in the hoop's channel all the way around. The glue drains downward through the tiny holes along the skin's perimeter, then dries, anchoring the skin securely in the hoop. Some drumheads go on to get a textured coating. By adding weight, the coating muffles the higher sound frequencies, enhancing the lower ones. This produces a warmer, deeper tone. It also produces that swooshing sound when jazz drummers play softly with brushes. Once the coating dries, a pad printing machine stamps on the company name. Only about 30% of drum heads on the market are coated. The rest are what is known as clear heads. So in other words, when it comes to drums, clearer heads prevail. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.